Let's dive into the fascinating world of physics with Dr. Sina G.
Wow. 7, 6, 5, 4, 3, 2, 1. Go, Nisar! Wow!
Yes, it is the GSLV F-16 rocket carrying the Nisar satellite. GSLV means Geosynchronized Satellite Launch Vehicle. This rocket at its initial stage contains propellants having a mass of 138 tons. The ignition of this propellants produced extremely hot high pressure gas that eject from the rocket through a small nozzle at the rear end of the rocket at increased velocity. We all know Newton's third law of motion. For every action, there is an equal and opposite reaction. The ejection of this extremely hot high pressure gas produces a downward force, which is the action. This in turn produces an equal and opposite force called the thrust, by which the rocket starts to move upward direction, which is the reaction. For the rocket to lift off, the upward thrust should be greater than the gravitational pull. Thus, the rocket accelerates in accordance with the Newton's second law of motion, that is F is equal to ma. In the initial stages of movement, the rocket ascends vertically because it has to escape from the drag force constituted by the thicker atmosphere as fast as possible. Once it reaches the thinner atmosphere, it starts to tilt sideways in a maneuver which is called gravity turn. The momentum of the rocket and the gravitational force helps the rocket to turn sideways and attain the desired horizontal velocity. Once the rocket reaches the designed destination, it will release the satellite. The combined effect of satellite momentum picked by the satellite from the rocket and the Earth's gravitational pull helps the satellite to move around the Earth in a circular path. In this slide, you can see that the Earth is orbiting the Sun in elliptical path and the satellite Nisar is circulating the Earth at an orbital altitude of 747 km. The satellite Nisar is a collaborative work of ISRO with NASA, where N stands for NASA, I for ISRO, SAR for Synthetic Aperture Radar. Nisar is the most advanced Earth observation satellite because it contains synthetic aperture radar technology in two frequencies. The S-band was developed by ISRO and the L-band was developed by NASA. Nisar is a sun-synchronized satellite having a weight of 2,392 kg. Nisar will scan the Earth at 12 days interval. For example, If Nisar scan Kerala today at 10 a.m., then it will repeat its scan in the 12th day at 10 a.m. itself. That's why it is called a sun synchronized satellite. Now let's have a look at the mission of Nisar. It provides all day and night data of Earth, provide information about ground deformation, ice sheet movement, vegetation dynamics, sea level rise, storm characterization, ship detection, disaster response, like that it is going. So our scientists, with the help of technology, developed NISA for humanity, and it is our duty to protect the earth. Jai Hind.